In this lesson, we're going to be learning about a variety of different triangles. First, we're going to start out with the equilateral triangle. Equa means equal, and lateral means side or line. So an equilateral triangle has equal sides. You can see that denoted by the blue dashes through our three sides. They're each a single dash, so that means that the three sides are equal. Now the sum of the angles of every single triangle is 180 degrees. And since our sides are equal, that means our angles are equal as well. And the three equal angles equal 60 degrees each, because 180 degrees divided by 3 is 60. And the sides, all equilateral triangles have the three sides of equal lengths, but the length is going to vary from triangle to triangle. You can have a really big equilateral triangle, you can have a really small equilateral triangle. The angles of 60 are going to be remaining constant, but the sides vary, what the quantity for the side is. Next, we're going to look at the isosceles triangle to the right here. So an isosceles triangle has two equal angles, and the two sides opposite our two equal angles are of equal length. So we have two equal angles, two equal sides. Then we have a third side that is different and a third angle that is different. And if we know one angle and which angle it is, whether it's angle A, one of the two similar angles, or angle B, the different angle, you can calculate all of the angles because there are only two different variables for the angles. We have two different values, so if we know one, then we just have to solve for one unknown. So you can say that the equation for finding the angles of an isosceles triangle is 2a plus b is 180 degrees. Now let's say that we knew that angle A was 70 degrees. We would get 2 times 70 plus b equals 140. And 2 times 70 is 140. So if we subtract 140 from each side, we get that angle B is equal to 40 degrees. Now let's say we know that angle B is 30 degrees. So we have 2a plus 30 equals 180 degrees. We subtract 30 from both sides to get that 2a is 150. Then we divide each side by 2 to get that angle A is 75 degrees. Now we're going to talk about right triangles. And these all to the left are different right triangles. You can see that there is that red square marking the right angle or the 90-degree angle. Now a right triangle has only one 90-degree angle, and the remaining two angles add up to equal 90 degrees because a triangle has 180 degrees. 180 minus 90 for a right triangle is 90. So a right triangle can have two equal sides or no equal sides. It can't have three equal sides because that would make it equilateral, and we don't have a 90-degree angle in our equilateral triangles. But you can have an isosceles right triangle or just a right triangle with three different sides. And the side that is opposite the right angle is always going to be our longest side, and that is called our hypotenuse. And we can use something called the Pythagorean theorem to find out the lengths of all the sides. So the Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. And if we have that side A is 4, side B is 3, and we want to find side C, we're going to plug in our known quantities and get 4 squared plus 3 squared is equal to c squared. We're going to simplify that to get 16 plus 9, which is equal to 25, is equal to c squared. Then we're going to take the square root of each side. So the square root of c squared is going to be plain c, and the square root of 25 is 5, so we get that c is equal to 5. You can also solve for an unknown side when you know one side and the hypotenuse. So if a is 7 and c is 8, we can solve for side b. So again, we're going to plug in the known quantities. 7 squared plus b squared equals 8 squared. We're going to simplify. We get 49 plus b squared equals 64, and we subtract 49 from each side to get b squared is equal to 25 to isolate the unknown variable. and we take the square root of b squared to get us plane B, and the square root of 25 is 5, so we get that side B is 5.